Hello everyone, today we're going to be working on question 4.1, and this question is asking us to determine the magnitude and direction of the moment of the force at A about point P. So here we have our force at point A, which we know is equal to 200 newtons, and point P is right here. So we're going to determine the magnitude and the direction of that moment. So to start off, remember that moment is equal to the force times the distance. So if we were to solve for the moment, we would write that it is assumed that counterclockwise is positive. So the moment about point P is equal to the force times the distance. So here we have a force of 200 newtons that is going downwards. Remember, when we're working with vertical forces or vertical components, anything going upwards is positive, anything going downwards is negative. So that's going to be negative. So we could write negative, and then from there, we have our 200 newtons. And then we know that we have to multiply our force by the distance. And as you can see, they give us two distances here. We have the 1 meter, and we know 2 meters. So if we look at this force, we know that this is a vertical force. And when we deal with vertical forces, we want that to align to our vertical axis. So from here, you want this to move so it could align with that y-axis. So we would be moving in a horizontal direction, which is why our distance would be 2 meters. Now, if our force was pointing in this direction, our 200 newtons going in this direction, since this is a horizontal component or a horizontal force, we would need that to align with our x-axis. And in that case, then our distance would be the 1 meter. But since this is a vertical force that we're working with, our distance would be the 2 meters. So we have our 200 newtons times 2 meters. From there, we input that into our calculator. We would get that the moment around point P is equal to negative 800 newtons times, sorry, not times, 800 Newton times meters, counterclockwise. But since we want to deal with positive numbers here, we could simply rewrite that as saying that the moment around point P is equal to positive 800 Newton meters clockwise. And like that, we were able to find our magnitude, which is the 800 Newton meters, and our direction, which is the clockwise, going clockwise.